Yes, good morning. Last lesson we had online, we got some confusion on file handling, where you asked about the text ln variable, which I said it is just a variable that stores line by line. I'm here to add more on it. So think of a file on a hard drive as like a closed textbook sitting inside a school bag. You get. So to use that textbook, you can't like just look at the bag then you use the textbook. You have to follow certain steps to open or write in the textbook or to read from it. So one of the steps, you can down the file or on the textbook as we've said. You can open the file, you can read the file, you can write to the file. Then also you have to show that this is the end of the file and you have to close it. So this is like the structure of how to write it, to write the command. You basically you open the command, then the file name, then for read, what I got for you is open my file.txt for read. So this opens the file and places the starting cursor at like the very top of the line. It opens at the very top of the line. That is what open file does. Then the read file, see my file.txt, then text ln, as you can see it here. This one, it reads one line of text, then saves it into the variable text ln and moves the pointer down to the next line. So this is like let's imagine you want to read a book. You want to read the book, so you can't read the whole textbook. You have to open the book, which we've seen. Then by reading, you can't read the whole page. You read line by line. God helped us that for us as humans, we have the brain which can store and remember. But for the computers, it is different. They have to store that one sentence of the line into that variable. You get. So you read one sentence from the page, and then you copy it into the temporary storage named the text ln. So explaining more about the text ln, this is it is a temporary storage. So when you read like a textbook, like I said, you can't read the entire book at once. You read one line, hold it in your head or write it down on a paper to work with it, and then move on to the next line. So why do we need the text ln variable? So when the computer executes the read file command, it grabs one line. The computer looks at the file and copies one single line of text. Then it holds the line. It places that text into the variable, the text ln. Then how you use that text ln. Now that your program can print the text ln to the screen, you can check if it contains a specific word or save it somewhere else. So basically, the text ln holds line by line as the computer is reading the file. So when like the process of outputting reaches, so the computer has to read that sentence, then stores it in the variable, then the variable outputs it, it writes it somewhere, then again the computer has to read the next line. Still that same variable is going to be used to keep that text ln, the content of that sentence, and then print it out. So that is how it works. It's like you reading your notes. You can't read the whole page at once. You have to read line by line, understand it, and then do what? Continue. That is how the computer is. I hope that helps, and if you find like any disturbance, you can call me. Then after that, I remember us looking at the abstract data types. Those were the stacks, the queues, the linked lists. Then we said a stack contains several operating items. Then it operates on last in, first out principle. Then items can be added to the stack through the push and the pop method. Then the queue, we saw for it, it operates on first in, first out principle. It can be added to the items can be added to the queue by the enqueue method, and removed from the queue by the dequeue method. So then we also introduced the linked list. This is a list containing several items in which each item in the list points to the next item in the list. So in the linked list, a new item is always added to the start of the list. Yes, it is added to the start of the list. Then we are going to see how you can delete from a linked list, how the pointers work and everything. So then the real world uses of stacks and queues and linked lists are mentioned down here. They're used for stacks are for memory management, then queues like in printer queues, managing the printing processes. Then then the linked list, implementing stacks with arrays, which I'm going to explain. We have already seen this. The stack is composed of the top pointer and the base pointer. Then the queue has the front pointer and the end pointer. So the key points here: the push adds a new item to the top of the stack. Pop removes the item from the top of the stack. From the top, you get. Then the base pointer points to the first item and stays fixed. Then the top pointer points to the last item added. So a stack becomes full when it reaches the size of its array. So the real world example, you can have the undo feature in word processing. Then the queue, we've already seen it has the front pointer and the end pointer, the enqueue and the queue methods. Enqueue adds a new item to the rear of the queue. This is like at the back or at the back of the queue. Then the queue removes the item from the front. Yes, you get. Then the front pointer changes after the queue operation. Array changes after an enqueue operation. So the real world documents waiting to print are held in the print queue. The first document sent is the first to be printed. Remember, the queue uses the first in, first out. Then the linked list, we said this one has pointers, and each pointer points to the next what? To the next node. So each node has like a memory and then address what? An address location. So the memory, or that part where like the information or the data is stored, then also the part where the next address of the node is stored. So yeah, let's find out in the next video.